February 9, 1943. The North Atlantic, 2,300 miles east of Newfoundland, where the ocean churns black under a moonless sky and the wind carries the taste of salt and diesel. Aboard the British corvette HMS Orcus, a young rating named Thomas Henley stands shivering in the cramped Aztec compartment, watching a small cathode ray screen flicker with green phosphorescent light. The glow illuminates his face in the darkness. Around him, the ship groans and pitches through 15-foot swells. Above deck, ice clings to the railings. Below, in the galley, men drink weak tea and wait. Henley stares at the screen, at the strange pulsing blips that appear and vanish like ghosts. He does not yet understand what he is seeing. In 6 hours, he will watch a German submarine die. The Battle of the Atlantic was not a single engagement. It was a grinding war of attrition that lasted nearly 6 years, from the first day of the European conflict in September 1939 to the final surrender in May 1945. It was fought across millions of square miles of ocean, in fog and storm and ice, by men who often never saw their enemy. The statistics are staggering. Over 3,000 Allied merchant ships sunk, 72,000 merchant seamen killed, 783 U-boats lost, and 28,000 German submariners entombed in steel coffins at the bottom of the sea. But the numbers alone do not capture the terror of those years. The nights when convoy escorts searched desperately for submarines they could not see, or the desperation of U-boat crews who believed themselves invisible hunters, masters of an undersea kingdom where detection was nearly impossible. For most of the war, they were right. And then, quietly, almost imperceptibly, the equation changed. Not because of grand strategy or brilliant tactics, but because of a technology so new, so untested, that many who first encountered it dismissed it as fantasy. Radar. The German submariners called it a myth, a propaganda tool designed to frighten them. They laughed at reports of Allied ships detecting submarines on the surface from miles away. They could not believe that invisible waves bouncing through the darkness could betray their position. And then, one by one, they vanished. The German Navy entered the war with confidence bordering on arrogance. Admiral Dönitz, the architect of Germany's submarine strategy, understood what many did not. Britain was an island, utterly dependent on imports. Food, fuel, raw materials, all arrived by sea. Sever those lifelines, Dönitz argued, and the British would starve. His U-boats would strangle the convoys. The mathematics were simple. If Germany could sink merchant ships faster than the Allies could build them, the war would be won in the Atlantic before it could be decided on land. In the first years of the conflict, Dönitz's strategy seemed to be working. U-boats prowled the convoy routes in wolfpacks, shadowing merchant fleets by day and attacking on the surface at night, when they were fastest and nearly impossible to spot. The submariners called this period the happy time, die glückliche Zeit. Between June and October 1940, German U-boats sank over 270 Allied ships. The losses were catastrophic. British ports ran short of food, rationing tightened. In London, officials quietly discussed contingency plans for surrender. The men of the U-boat service believed they were invincible. They had reason to. At night, on the surface, a submarine's low profile made it almost invisible to the naked eye. Allied escorts relied on lookouts straining through binoculars, hoping to catch a glimpse of a dark shape against darker water. Even in calm seas, the chances of detection were slim. In rough weather, they were negligible. And if a U-boat did submerge, the Allies' only weapon was Aztec, a sonar system that could detect submerged submarines but was useless against targets on the surface. The Germans knew this. They exploited it ruthlessly. Surface at night, attack, dive at dawn. It was a formula that seemed unbeatable. But in the summer of 1940, British scientists working in secret laboratories had achieved something extraordinary. They had developed a functional centimetric radar system, operating on wavelengths short enough to be mounted on aircraft and ships. Unlike earlier radar systems, which were bulky and imprecise, this new technology could detect small objects, like the conning tower of a surface submarine, at distances of several miles. The device was called the ASV Mark II, Air-to-Surface Vessel Radar. It would change everything. The first units were installed on RAF Coastal Command aircraft in early 1941. The results were immediate. U-boats that had felt safe on the surface suddenly found themselves illuminated by invisible beams, attacked without warning by planes emerging from cloud cover or darkness. The submariners were baffled. How were the British finding them? Dönitz received reports of inexplicable attacks, submarines surprised in mid-ocean, bombed before they could dive. Crews reported seeing aircraft appear out of nowhere as if guided by magic. The German High Command was skeptical. Radar, they reasoned, was too primitive to detect something as small as a submarine. The Allies must be using some other method, perhaps breaking German codes or deploying new types of sonar. Some officers speculated about infrared detectors or advanced listening devices. A few suggested spies, but radar, impossible. The wavelengths required would be too short. The technology did not exist. It was propaganda, they concluded, designed to spread fear and uncertainty among U-boat crews. Dönitz issued orders. Ignore the rumors, trust your training. The sea is still yours. They were wrong. By 1942, centimetric radar was being installed on escort vessels. The Type 271, a surface search radar developed for the Royal Navy, could detect a surfaced submarine at ranges exceeding 5 miles, even in heavy seas. The device used a rotating antenna housed in a distinctive lantern-shaped radome, which gave it the nickname the Cheese. It was ungainly, temperamental, required constant maintenance. But it worked, and it was lethal. The turning point came slowly, almost invisibly. In the early months of 1943, Allied losses began to decline. Not dramatically. The U-boats were still dangerous, still sinking ships, but the trend was unmistakable. More submarines were being detected. More were being attacked. Fewer were returning to base. The German submariners began to sense something was wrong. They reported strange incidents. Escort ships changing course directly toward them in total darkness. Aircraft attacking through solid cloud cover. Depth charges dropped with uncanny accuracy. The old tactics no longer worked. Surfacing at night was no longer safe. But the truth was slow to penetrate the German command structure. Dönitz continued to believe in the invincibility of his wolfpacks. When U-boat losses spiked in the spring of 1943, he attributed it to increased Allied air patrols and improved anti-submarine tactics. He did not understand that the Allies could now see in the dark. The men aboard the U-boats knew better. They felt it in their bones, the creeping realization that they were being hunted by something they could not comprehend. Oberleutnant Sir C. Peter Kremer, commander of U-333, described the sensation in his memoir. "We felt naked," he wrote, "as if we were moving through a lighted room while our enemies watched from the shadows. We could not see them, but they saw us, always. The fear was corrosive. Submariners who had once joked and played cards in the control room fell silent. They jumped at sounds. They argued. Some refused to surface, even when batteries were low and the air grew foul. The psychological toll was immense. These were men who had been trained to believe in their superiority, their technological edge. They were hunters, predators. And now they were prey. The transformation was devastating. Morale collapsed. Crews began to question orders. Some boats turned back from patrols without engaging the enemy. A few surrendered at the first sign of attack. The myth of U-boat invincibility was dying, replaced by something darker. The knowledge that the sea had betrayed them, that invisibility was an illusion, and that death could arrive without warning from machines they could not see or understand. The evidence was mounting. In March 1943, the Allies sank 15 U-boats. In April, 15 more. In May, the numbers became catastrophic: 41 submarines destroyed in a single month. It was the worst loss rate in the history of the U-boat service. Dönitz was forced to confront the truth. On May 24, he issued a stunning order. All U-boats were to withdraw from the North Atlantic. The wolfpacks were recalled. The Battle of the Atlantic was not over, but the initiative had shifted irrevocably. For the first time since 1939, Allied convoys crossed the ocean without significant loss. The German submariners who survived the spring of 1943 spoke of it with something close to awe. They described a sea that had turned against them, a hunting ground transformed into a killing field. They told stories of boats that simply vanished, last heard from one evening and never seen again. They remembered comrades who reported being attacked by invisible enemies, tracked across miles of open ocean by forces they could not perceive. And they remembered the moment when the truth finally became undeniable. The Allies had radar. Real, functional, lethal radar that could pierce darkness and storm and detect a submarine from distances that seemed impossible. The mocking disbelief turned to fear, then to despair. The technology itself was almost absurdly simple in principle. A transmitter sends out pulses of electromagnetic energy. Those pulses travel at the speed of light until they strike an object, then bounce back. A receiver detects the returning signal and measures the time delay. From that, a simple calculation yields distance. It is the same principle that allows a bat to navigate in darkness, or an echo to reveal the walls of a canyon. But making it work at sea, in combat, against targets as small and elusive as submarines, required engineering genius. The key was the cavity magnetron, a device developed by British physicists John Randall and Harry Boot at the University of Birmingham in early 1940. The magnetron could generate extremely high-frequency microwaves, wavelengths measured in centimeters rather than meters. These short wavelengths allowed for compact antennas and precise targeting. The device was small enough to fit in an aircraft or a ship, yet powerful enough to detect objects at useful ranges. When British scientists first demonstrated the magnetron to American officials in September 1940, the response was electric. American engineers immediately recognized its potential. Within months, the United States had established the Radiation Laboratory at MIT, staffed by some of the best scientific minds in the country, with the sole purpose of refining and mass-producing radar systems. By 1943, thousands of sets were in production. The Allies had achieved a technological breakthrough that the Germans had believed impossible, and they had done it in secret. The irony is that Germany had its own radar program. German scientists understood the principles. They had built early warning systems to detect Allied bombers, but they had focused on long-wavelength systems, which were easier to produce but less precise. German engineers believed that centimetric radar was impractical, that the technical challenges were insurmountable. They were wrong, and the error cost them the Battle of the Atlantic. The U-boat crews paid the price for that miscalculation. By mid-1943, the odds had reversed completely. A submarine that surfaced in the North Atlantic had perhaps a 50% chance of being detected within minutes. If an aircraft was in the area, the odds climbed higher. The hunters had become the hunted, and there was nowhere to hide. The ocean, once a sanctuary, had become a trap. The Germans tried to adapt. They developed radar detectors, devices called medocs that could supposedly warn of Allied radar emissions. But the detectors were crude, unreliable, prone to false alarms. Worse, they operated on the wrong frequencies. The early models could not detect centimetric radar at all. By the time upgraded versions appeared, it was too late. The damage was done. U-boats equipped with detectors were still being sunk at appalling rates. Some crews disabled the devices, believing they were useless or even dangerous. Others kept them running, staring at the receivers, hoping for a warning that often never came. The symbolic object of this transformation was not a weapon or a tool, but a screen. That small, glowing cathode ray tube in the radar operator's compartment. It was an unassuming thing, no larger than a dinner plate, its surface coated with phosphorescent material that glowed faintly green in the darkness. On that screen, the ocean became visible. Distance, bearing, speed, all translated into geometry, into blips and lines that moved with eerie precision. The radar operator sat before it like a priest before an altar, interpreting signals from an invisible world. To the men who operated these systems, the screen was almost magical. It showed them things that should have been impossible to see. Ships beyond the horizon, aircraft concealed by clouds, submarines cloaked by night. The green glow became a symbol of mastery, of technological dominance, of the moment when human ingenuity overcame the limitations of the senses. For the Germans, that same screen, or rather, the knowledge that it existed, represented something else. It was the embodiment of their obsolescence, proof that the rules of warfare had changed in ways they had not anticipated and could not counter. The sea had always been opaque, a hiding place. Radar made it transparent, and transparency meant death. There is a recording, preserved in British naval archives, of a radar operator aboard the destroyer HMS Hesperus, describing the detection and sinking of U-191 on April 23, 1943. His voice is calm, matter-of-fact, almost bored. Contact bearing 285, range 4,000 yards. Closing. Target appears to be surfaced. Recommend attack. 30 minutes later, U-191 was gone, destroyed by depth charges before it could dive. All 53 men aboard were killed. The operator's tone never changed. It was routine. By the spring of 1943, it had become routine. Submarines that would once have escaped undetected were now being destroyed with mechanical efficiency. The green blips on the screen were not enemies or human beings. They were simply targets, problems to be solved with mathematics and explosives. The emotional distance was complete. This, too, was part of the transformation. Radar did not just change tactics. It changed perception. It reduced the terror and chaos of naval warfare to geometry, to angles and ranges and vectors. It made killing abstract, almost clean. The men who operated the systems rarely saw their victims. They saw only the screen, the blips, the data. And when a blip disappeared, they moved on to the next target. By the war's end, the statistics were irrefutable. In 1943 alone, the Allies sank over 240 U-boats. The number of merchant ships lost in the North Atlantic declined by more than 60% compared to the previous year. Radar was not the only factor. Improved tactics, increased air patrols, better depth charges, and the breaking of German naval codes all played crucial roles. But radar was the foundation. It was the technology that made everything else possible. It gave the Allies eyes in the darkness, and once they could see, the outcome was inevitable. The German submariners who survived the war spoke of radar with a mixture of bitterness and awe. They had been trained to fight an enemy they could see, to navigate by stars and currents, to trust their instincts and their courage. Instead, they were destroyed by invisible waves, by signals they could not perceive, by an enemy who watched them from beyond the reach of human senses. It felt like witchcraft, like betrayal. One veteran interviewed decades later said simply, "We thought we were the future. We believed technology was on our side. We were wrong, and we died for that mistake." His voice carried no anger, only exhaustion. The exhaustion of a man who had believed in something absolutely and discovered, too late, that belief was not enough. The epilogue of this story is not written in battle reports or casualty figures, though those tell part of the truth. It is written in the quiet transformation of naval warfare, in the shift from a world where the ocean was opaque to one where it was transparent, from a contest of courage and seamanship to one of signals and electronics. Radar represented something larger than a tactical advantage. It was proof that the democracies, when pressed, could innovate faster and more effectively than their enemies. The Axis powers had begun the war with confidence in their technological superiority. German submarines were the finest in the world. Japanese aircraft carriers dominated the Pacific. Italian engineers designed elegant, deadly warships. But the Allies had something else: a willingness to invest in unproven ideas, to support scientists and engineers whose work seemed abstract or impractical, to bet on technologies that did not yet exist. The cavity magnetron was developed in a university laboratory by two researchers working with equipment that cost less than £1,000. It was not the product of vast military-industrial planning. It was an experiment, a gamble, an idea pursued because it might work. And when it did, the Allies had the infrastructure, the manufacturing capacity, and the coordination to turn that idea into thousands of functional radar sets deployed across two oceans. That capacity, the ability to translate innovation into mass production, to adapt quickly to new information, to trust in the scientific method, was itself a kind of abundance. Not abundance of resources alone, though that mattered, but abundance of imagination, of willingness to change, of faith in human ingenuity. The green screen, glowing in the darkness of a warship's radar compartment, was a symbol of that faith. It represented the belief that problems could be solved, that ignorance could be overcome, that even the vast and trackless ocean could be made legible through reason and technology. The German submariners who mocked radar were not fools. They were men trained in a different tradition, one that valued discipline and courage and the mastery of established techniques. They did not believe that the rules of warfare could change so quickly, so completely. They could not imagine that the sea itself might betray them. But the sea does not take sides. It is indifferent to valor, to tradition, to ideology. The Allies understood this.